Hello everyone, welcome back to the channel. In today's video, we are going to talk about one of the most important concepts in networking, that is IP addresses. So in this video, we will be covering what an IP address is, type of IP addresses, private and public IP addresses with their ranges, static and dynamic public IP, ranges of IP that are IPv4 and IPv6, why IPv6 was required when IPv4 already existed. So without wasting much of our time, let's start our video. So let's move to our first slide, that is IP addresses. So what an IP address is? So in IP addresses, IP does stand for Internet Protocol. So IP addresses is basically a unique identifier assigned to every devices connected to a network. So just like your home addresses help the postman delivers letter, and IP addresses help data packet reach the correct device on a network or the internet. So without the IP addresses, devices would not be able to communicate with each other. So why do we need IP addresses? We have to understand, right? Why do we need IP addresses? So we need IP addresses due to, like, to identify devices on a network, enable communication between devices, send and receive data over the internet, track and manage network traffic. So these are the few points why we actually need IP addresses. So in if we see in regards to SOC, so SOC Analyst uses IP addresses to detect suspicious connections, track attack sources, identify compromised systems, and to analyze logs and alerts. Okay, so this is IP addresses, which are actually a unique identifier. Why do we need IP addresses? These are the few points because of which we need IP addresses. And if we see in respect to SOC, why SOC need IP addresses? Like detecting suspicious connection, track attack sources, identify compromised system, analyze logs and alert. Okay, so moving to the types of IP addresses. So broadly, IP addresses can be classified into two types. That is public IP addresses and private IP private IP addresses. Okay, so we'll discuss what each one in detail. So first we'll move forward with private IP addresses. So private IP addresses is used inside a local network, used inside a local network, like home networks, office networks, school and colleges. So these IP addresses cannot be accessed directly from the internet, and these IP addresses are non-routable addresses. Okay, so private IP address ranges are basically class A, class B, and class C. So the private IP addresses are divided into three ranges mostly, that is class A, class B, and class C. So class A falls between this, class B falls between this, and class C falls between this. Okay, so devices like laptop, mobiles, printers, and smart TVs usually have private IP addresses, and this is one of the example of private IP addresses. Okay, so this particular range, if we see this particular range fall between class C. Okay, moving to our second type of IP address, that is public IP address. Okay, so a public IP address is basically assigned by your ISP. Okay, assigned by your ISP. ISP is Internet Service Provider, and this public IP addresses is used to communicate over or with the internet. So these IP addresses is globally unique and reachable over the network. So each network typically has one public IP that represent all the internal devices. Okay, so public IP addresses are again divided into two types, that is static, second one is dynamic. So static means it does not change. It is basically used by hosting services, servers, businesses. Okay, and these are actually compared to dynamic, these are more expensive. Okay, moving to the dynamic. Dynamic means, by the name itself we can say it changes periodically. These dynamic public IP addresses are assigned automatically by the ISP. What does ISP is? Internet Service Provider. So it is basically used by most home users like us. And these are cost effective and secure compared to the static IP addresses. Okay, understood? Moving to our next slide, that are IPv4 and IPv6. So these are versions of IP addresses. So there are two versions, that are IPv4 and IPv6. So first we'll try to understand the first version, that is IPv4. So IPv4 is most commonly used IP version. Okay, so this is 32-bit addresses. Okay, second thing is it's written in decimal format. This is one of the example. So total possible IPv4 addresses can be around 2 to the power 32, that is approximately 4.3 billion IPv4. Okay, so moving to our IPv4 structure. So IPv4, as already discussed, IPv4 are 32, yeah, IPv4 are 32-bit addresses which are divided into 4 octet, and each octet equals to 8 bits. Okay, now moving to our second version, that is IPv6. So IPv6 was basically introduced to solve IPv4 limitation. Okay, so IPv4 uses 128-bit addresses. It is written in hexadecimal format. This is one of the example of IPv6 and how it's written. Okay, so this particular, if you see an example here of IPv4, it's written in decimal format, and if you see this IPv6, it's actually written in a hexadecimal format. Okay, if we see the total possible addresses in IPv6 version, that are approximately 2 to the power of 128. That is actually a huge number. Okay, so there is a limitation of IPv4 compared to the IPv6. Okay, so IPv6, if you talk about IPv6, there are enough IP addresses for every device on earth, and yeah, much more actually. Okay, so why IPv4 was not enough? Okay, why IPv4 was not enough? What was the reason of introducing IPv6? If we already had IPv4, then IPv6, why? Okay, so as already discussed, initially around 4.3 billion addresses seemed seemed more than enough. Okay, which were IPv4. Okay, there were around 4.3 billion IPv4 addresses. Okay, so as with more smartphones, with more IoT devices, with more smart homes, IPv4 was not enough. So we started running out of IPv4. So this particular problem of running out of IPv4 addresses is named as IPv4 exhaustion. Okay, so IPv6 allow every device to have its own unique IP addresses, improving speed and security. So temporary solutions like NAT helped initially, but they were not permanent. Okay, so I'll give you the points why IPv6 was required. Okay, so first point is due to IPv4 address exhaustion. Second was growing number of devices like smartphones, smart homes, IoT devices, and much more. After that, IPv6 for better performance and better routing compared to IPv4. It, it has built-in security and IPv6 doesn't need netting. Okay, so IPv6 is not just about more IPs, it's about a better and the scalable internet. Okay, so let's have a quick comparison between IPv4 and IPv6. So let's move to the features and IPv4 and IPv6. So address size, address format, total address, yeah, NAT requirement, security, speed and efficiency. Features IPv4 and IPv6. So let's have a comparison. Okay. So IPv4 is 32 bits, IPv6 is 128 bits. Address format is written in decimal, IPv6 has hexadecimal format. Okay, so total address is approximately 4.3 billion. And if we talk about IPv6, it's actually almost, I would say, unlimited. NAT required for IPv4? Yes, required. For IPv6, as already discussed, no need of NAT, that is not required. Security, it's optional in for IPv4 and in IPv6 it is built in IPsec. Speed, talk if we talk about IPv4, it's less and in IPv6 it's more. Okay, so this was the basic reason why IPv6 was actually introduced and IPv4 was already there. Okay, so today we learnt about what an IP address is, private plus public IP addresses, ranges of IP addresses, version of IP addresses, and the main point is why IPv6 was introduced. Okay, so this was the end of our this particular video where we discussed about the IP addresses and multiple other topics as well. So in the next video, we will be covering about NAT and PAT. Okay, so if you found this video helpful, like, share, and subscribe to the channel. Thanks for watching, and I'll see you in the next one. Thank you, everyone.